Hi guys, welcome. So in this video we'll be discussing about the different metrics which we use to validate our classification model. So in this video we'll be discussing about the binary classification model where usually the classes are ones and zeros. Positive classes are the ones and negative instances are the zeros. So before moving on to the metrics which we are going to discuss, let's see what are those metrics, and then in detail we'll be discussing each and everything. So first is accuracy, second is confusion metrics, sensitivity, specificity, precision, recall, F1 score, TPR, FPR, TNR, ROC, AUC. I know this list looks exhaustive and it does confuse a lot of people while answering. If during interviews, if someone asks what is sensitivity, people do confuse so what to answer, because most of them are quite similar to the other. And to avoid this confusion, let's go and check out what is confusion matrix. So let's go to my whiteboard and see what is confusion matrix and remove all the confusion regarding all these terms. So welcome to my whiteboard where I've drawn a very weird kind of table, and it does not look good, but trust me guys, I have a good handwriting, and so do not judge me on this handwriting. Anyways, let's move on. So let's take a dataset example where we are predicting if a person has cancer or not. So let this value be 3000. I'll let you know each and everything. Just let me draw this matrix and it will be very clear to you. So I'm just putting some random numbers here and I'll explain you what this means. Okay, so these are the predicted values and these are the actual values. That means 3000 data points are actually the person's having the disease, and the model has already predicted that these person have the disease. So the number is 3000 in this case. Again, 300 is our model is predicting as the persons have cancers, but actually they do not have cancer. And in this field we have who have cancers, but then our model is predicting these are the peoples who do not have cancer. And again, in this field our model is predicting that the person have cancer and actually the person have cancer. So these matrix is known as confusion matrix. What happens is usually, or most of the cases, you guys will be getting a rare case problem where the data will be skewed towards one classes. That means either the positive classes or the negative classes will be more. That means either class 1s will be more and class 0 will be less. So this is a skewed problem, and what happens, our predictor while predicting puts a lot of weightage towards the classes which are more in number. So we'll see why accuracy is not enough in this case. If we see our accuracy, this one plus this one, that means 3700 divided by the total number, which is 3300, 600, 700, 4600. And in this case our accuracy is somewhere around 80%. You guys can calculate. This is more or less it will be, 80%. So our accuracy is pretty good. So what's the problem here, right? If we go and tell our stakeholders that we have a model whose accuracy is around 80%, he or she, if they do not have any idea about these rare case problem, will be very happy that our model is doing really good job. But then if you can see here, few of the person who have cancer, but then our model is predicting them as they do not have cancer. Yes, this is the field where our predictor is telling that persons do not have cancer, however they do have cancer. So in these type of problem it becomes little difficult, because there is a risk factor involved, right? I mean, there will be lot of fatal cases in this case, and you do not want your predictor to behave in such a way where it is not able to predict the class which is very important. So accuracy is not enough in this case, and there are different metrics which we'll look now. So these fields which we saw just now are known as true negative, false positive, false negative, and true positive. So what this means is 3000 number of cases which are predicted correctly by our model who do not have cancer. So these are the negative instances which we have taken as zero classes. As I said, the class which is more important is usually given ones, that means usually is classified as ones. So that's why this is called true negative. False positive, that means the predictor is predicting few of the cases as people having cancer, however in actual they do not have cancer. This one. And in the third segment what we have is actually the people have cancer, however our predictor is not behaving well and it's predicting as non-cancer. And in this section it is correctly predicting whoever have cancer. So that's why this is called true negative and true positive. This one is false negative and false positive. Why is it called negative and positive? I have made a detailed video regarding this. You can check it out and find out why it is called negative and positive. In short, these are called positive classes because these are ones which our model is predicting as ones, and negative, these are negative instances which are labeled as zeros. Hence these are called negative instances. Now this is called the confusion matrix, as I said. So if we sum this field and this field, it becomes 3300. These are the actual classes, I mean the actual number of data points in the training data who are non-cancer patients. These are the actual data points, okay? And if we sum this one and this one, that becomes 1300. So these are the actual cases where the people have cancer. These are the actual data points. And if we sum this one and this one, these are the predicted values. That means 3600 times the model has predicted the values are non-cancer, and 7 plus 3, that is 1000 data points are predicted by the model who are cancer. So let's look at something which is called as sensitivity. So sensitivity, the formula is given by TP by TP plus Fn. So sensitivity, what it tells is, now TP is this 700 and Fn plus TP is the actual number which is in the training data, actual number of persons who have cancer. So this entire matrix tells us how many out of the actual number, how many our model predicted correctly. So this one will be 700 divided by 1300. I know it's little confusing, I'm going to repeat myself again. So the sensitivity tells us out of total number of classes which are cancer patients, that means which belong to ones, our model is predicting correctly, how many numbers it is predicting correctly. TP divided by TP plus Fn. So in this case it will be 700 divided by this value 1300. 700 divided by 1300 will be somewhere equal to 53%, which is not a good sign, right? I mean, 53% of the time the model is predicting correctly that the person have cancer, but the rest, almost 50% of the time, the model is misclassifying. So in this sensitivity, we get a lot of idea about how the model is performing. If we just look at the accuracy, it's not enough, right? It has a lot of different names. Usually it is known as recall when it comes to biochemistry or medical fields. TPR, that is true positive rate. So these three are mostly used interchangeably. If your interviewer asks you what is TPR or what is recall or sensitivity, so these three are all the same. So next, with TPR comes the next, which is precision. Usually people get confused with recall and precision because more or less they are quite similar. So let's see what precision is. So the next matrix which we will see right now is known as precision. So precision is given by the formula TP divided by TP plus FP. So if we look into the confusion matrix, TP is this point and TP plus FP is the total number of data points which are predicted by our model and that belongs to the positive instance, that means class 1. So 1000 data points is predicted by our model are belonging to class 1. These are the predicted points, right? In the columns we have the predicted values, in the rows we have the actual values. So TP by TP plus FP tells us out of total number of positive classes predicted by our model, how many are actually belonging to positive classes, that is 700 divided by 1000, right? I'm going to repeat myself again. 1000 is the number of data points predicted by our model which belongs to positive class. So out of 1000, how many are actually positive? What is the percentage, predicted percentage actually belonging to class 1? So this precision matrix tells us what is the percentage. So if we do the calculation here, it will be 700 divided by 700 plus 300. So 70% of the time our model is predicting correctly. Now let's understand what specificity means. So earlier we saw what sensitivity means, which is nothing but recall or the true positive rate. Similar to true positive rate, we have something which is called true negative rate, which is given by the formula, Tn divided by Tn plus Fp. So let's see what is Tn plus Fp. So Tn plus Fp is nothing but 3300 in this case. That means this is the actual value of persons who do not have cancers in the training data, and out of this value, how many the model is able to catch. So out of 3300, the model is able to catch 3000 values who do not have cancers. So in short, specificity provides us by the percent or proportion of zeros correctly classified. So specificity provides the percent or proportion of zeros correctly classified. We can see this, right? Tn is the proportion of zeros correctly classified by our classifier, and the total here is 3300. So with this, let's now move into the next one, which is known as false positive rate. So there is always a need to find out how many data points our model has incorrectly classified as positive instances. That means how many data points are classified as cancer patients. So what we do in this case is we find out the false positive rate. So false positive rate is given by FP divided by TN plus FP. So let's see, TN plus FP is again 3300. So these are the actual non-cancer patients value, and FP is the misclassification which we have got from our model. So now if we see what FPR is nothing but it's equal to 1 minus TNR. Now as we saw what TNR is true negative rate that is given by TN plus FP. You can just go a little backwards and find out what TNR is. So if we substitute the value here, we get FPR, which is FP divided by TN plus FP. So earlier we saw what precision and recall means. We saw it in detail, what is the formula and the explanation. So in short, precision is the proportion of predicted ones that are actually won in the training data. Whereas recall or sensitivity is the actual percentage of ones correctly classified by our classifier. So this is the precision and recall. It is often combined and used in a single matrix, which is known as the F1 score. So F1 score is the harmonic mean of precision and recall. So I'm not going into the proof of this one. It will make the video lengthy. If you want the proof, I'll show it in some other video. So for now, we'll consider this as F1, which is the harmonic mean. So what happens is it usually gives more weight to lower values. So if we solve this, we get something like 2 into precision into recall. So if we bring these two in the numerator, it will be 2 into P into R, and this one will be divided by P plus R, which is nothing but TP divided by TP plus Fn plus Fp divided by 2. If we solve this, we are going to get this value. So what happens is the classifier will only get a higher F1 score if both the precision and recall both are high. So it's usually used when we are when we are considering more than one or two classifier and comparing the F1 scores. So usually this one will only go up when both precision and recall both are high. If one of them is low, the F1 score will go down. There is always a trade-off between the precision and recall. So if one goes up, the other goes down. It is bound to be like that. So sometimes we care about the precision and sometimes we care about the recall. Actually, it depends on the business scenario, what business condition you are working with, and which classes you would want to put more attention to. So it depends upon that. So with that, we will move into the next metric. So the next matrix is one of the most important when we are considering comparing a lot of classifiers. So this is the ROC and the AUC. ROC is known as the receiver operating characteristic curve, and AUC is the area under curve. So this line, which makes 45 degree with the x-axis, this line shows that the model is completely random guess model. So the AUC will mostly be above 0.5 and if anything goes below zero point 0.5, that means the area under curve or the model is not a good model. So what ROC is a plot between the true positive rate and FPR. Whatever at different cutoffs, if we see the TPR and FPR, then the graph will be somewhat like this. I mean, this curve will be hugging the TPR axis. So I have made a complete video explaining the TPR and FPR with different cutoff value. You can go and check it out. You'll get a better understanding if you see. So the next, if we see what TPR is the sensitivity, right? And FPR is nothing but 1 minus TNR, that is 1 minus specificity. So we can see TPR rises, FPR also rises. That means if sensitivity rises, 1 minus TNR rises, that means TNR decreases, right? So if specificity decreases, sensitivity increases, and vice versa. And always try to get a AUC which is more or less near about equal to 0.9 or 0.8. If it is 0.9, then it's a very good classifier. So this was it for today's video. I have explained each and everything in detail. I don't think so you guys will have confusion regarding this. And hopefully now you know when you are using a binary classifier, you are not going to go with the accuracy. So if the interviewer asks you, or if you are explaining your logistic regression or binary classification model to your interviewer, it's better if you tell him or her about the TPR, FPR, precision and recall things rather than accuracy, or interviewer will be more than happy. Choose the appropriate metric for your task as per your business scenarios. Evaluate your classifiers using different cross-validation methods, and find out what is the good trade-off that fits your needs, and compare different ROC and AUC values. So I think if you measure all these and take care of these metrics, you will have a definitely good model. So that was it for today's, guys. Let me know in the comments what you think, and if you have any question, you can ping me in LinkedIn, or you can comment down below. Thank you again for watching this video, and please do subscribe. This will help me reach people who really need this type of help. And every week I'll be uploading videos regarding data science and machine learning algorithms. Thank you so much. Again, we'll see you soon.